Hello, this is Mr. Huber. In this lesson, we're going to learn about another method for solving quadratic equations by taking square roots on both sides of the equation. So we can use this method only if there's a variable squared with no bx term. Okay, this is very important. So only use this method if you have the quadratic equation with your x squared and no bx. Remember, ax squared plus bx plus c. If that bx is 0 and it's not there, then you can use it. So for instance, if I had 2x squared plus 7x minus 8 equals 10, I would not be able to take square roots on both sides to solve because I've got this 7x there. Okay, so I would not be able to use this. So I would not be able to use square roots on both sides in a situation like that. The problems we're going to see coming up, we're going to notice, like in number 1, you can see there x squared minus 17 plus 19. All right, I've got the x squared. I've got no term with just an x in it. And this next one over here, I've got the 3x squared. I've got no term with just an x in it. Right? There's no bx term in either of these equations. So that's where we can use taking square roots. And how are we going to do that? Well, we're going to get the x squared isolated by itself. So when you're solving this, you want to get this x squared by itself. How can we do that? Well, we're going to solve the equation like we would any other time using inverse operations. So we can add 17 to both sides. So we add 17 to both sides. That cancels out, and we have x squared equals 36. Now when we get the x squared all by itself, this is when we can square root both sides of the equation. So we can take a square root on both sides. Because what would be the square root of x squared? Right? The square root is what times itself. Well, what times itself would give me x squared? It'd just be x. So that's how we can get the x by itself. No squared anymore. And on the other side, the square root of 36 is 6. It's very important. This is one of the key things to keep in mind when you square root both sides. You have to have plus or minus whatever that square root is. You have to include plus or minus because I could go back in here and plug in negative 6. And when I square it, I would still get a positive 36. Or even better, I should take these and plug them back into the original equation. All right, so I can plug in a positive 6 squared is 36, minus 17 is 19. When I plug negative 6 in, again, negative 6 squared is a positive 36. Minus 17 will equal 19. So I got my two solutions, 6 and negative 6. Right now it's the plus or minus 6. Anytime you square root both sides, you have to include that plus or minus in front of whatever that square root is going to be. All right, in this next problem, right, again, we want to isolate the x squared and get it by itself. So what do I need to do there? I need to divide by 3. So I can divide by 3 on both sides. And when I do that, right, the 3 is going to cancel. I'm going to get x squared equals 25. Now I can square root both sides. I'm going to get x equals plus or minus 5. So 5 and negative 5 are both solutions to that equation. Going ahead to number 3 here. 5x squared plus 11 equals 11. So we're going to get that x squared by itself by subtracting 11 on both sides. And we'll get 5x squared equals 0. Then I have to divide by 5. So in this case I'm adding and subtracting and I'm dividing here to get the x squared equals 0. And when I square root both sides of this, the square root of 0 is 0. I don't have to have a plus or minus here because 0 and negative 0 are just the same thing. So when you square root 0, you will get just one solution. We've seen that other times when we solve with different methods. Right? We can get two solutions. That's most common when we're solving quadratic equations. But we don't have to get two solutions. This is the time where we got just one solution. In this case, x equals 0 as our one and only solution. So when you're square rooting 0, you're going to get just that one solution. All right, and number 4, we're going to subtract 10 on both sides. And we get negative 2x squared equals 98. And now when I divide by negative 2 on both sides, x squared equals 98 divided by negative 2 would be a negative 49. And when you go to square root this, we're going to have to recognize that when we're square rooting a negative, we'll be trying to find a number times itself that gives us negative 49. There is no number times itself, no real number that will give us negative 49 when we multiply it by itself. Because if we had 7 and 7, that would multiply to give us a positive 49. Negative 7 and negative 7 would multiply to give us a positive 49, not negative 49. So we see this is one of our other special cases we've seen before in different situations. No solution. Okay, there's no solution for that equation when you square root the negative. Make sure it's at the end when you get the x squared by itself. Right up here it had 108. That was positive. Okay, we could square root that. Right? But when we get the x squared by itself, when we go to square root both sides, we cannot square root the negative in that case. Let's try a couple more. You should be trying these as we go. For number 5 here, we have 16x squared minus 8 equals 1. So what am I going to do here is add 8 on both sides. I get 16x squared equals, that's an 8, right? So equals 9. And now when I divide by 16 on both sides, I'm just going to keep this as a fraction. X squared equals 9 over 16. And when I square root both sides, x equals plus or minus square root of 9 is 3, or the square root of 16 is 4. So plus or minus 3/4. Right? You just keep it as a fraction. When you square root a fraction, you square root the numerator and denominator separately. In this next example, we're going to add 7 to both sides. We're trying to get this x squared by itself. And now we're going to divide by 4 on both sides. We're going to x squared equals 5. All right, so in this case, when we square root, there's no exact integer solution for the square root of 5. Right? You're not going to know a number off the top of your head that times itself gives you 5. It's going to be a never-ending decimal. It goes on forever, never repeats, never ends. It's an irrational number. We're still going to have a plus or minus, so you're going to have to put this in your calculator. Plus or minus, we'll go 2 decimal places, so we'll go to the hundredths place. So 2.24. It's 23606, so 2.24. Still plus or minus, right? So sometimes you're going to get numbers like that where when you square root them, right, you might need a calculator to give a decimal approximation for that answer. All right. A little trivia here. You might be hearing the theme song in your head to Sports Center when you see that da-da-da, da-da-da. What does ESPN stand for? It stands for Entertainment and Sports Programming Network. When ESPN was founded in 1979, they didn't think that it was going to be something that people would be able to watch sports 24 hours a day. So they called it the Sports and Entertainment Network because they thought they'd have to fill in other time with things other than sports. Clearly, they were able to fill 24 hours of sports in a day, and it has boomed since then. So ESPN, the Entertainment and Sports Programming Network. And we continue to see some more solving by square rooting. Something a little different in number 7 here, because we have everything in parentheses being squared. That's what we want to isolate by itself. We want to get this part of the equation isolated by itself. Okay? So we're going to divide by 2. So we're going to divide by 2 on both sides, because that cancels out the multiplying by 2 on the left side. It's multiplying that whole parenthesis, so we can just eliminate it by dividing by it. We have x minus 4 squared equals 18 divided by 2 is 9. Now I want to square root this because that whole left side of the equation is being squared. The x minus 4 is all being squared. And so when I do that, I'm going to get x minus 4 by itself equals plus or minus 3. Okay? So we have here x minus 4 equals 3, and we also have x minus 4 equals negative 3. Right? X minus 4 is equal to plus or minus 3. So we're going to have 2 different equations to solve to get our 2 different solutions. So here when I add 4 to both sides, I'll get x equals 7. Here when I add 4 to both sides, I get x equals 1. So 1 and 7 are my 2 solutions to this equation. And keep in mind, I could take those and plug them back in up here. For instance, 7, I plug in 7, minus 4 is 3. 3 squared, got to follow the order of operations, is 9. Then I would have 9 times 2, which is 18, equals 18. And if I plug in the 1, it will also work. 1 minus 4 is negative 3. Got negative 3 in parentheses, being squared, times itself is 9, times 2 is 18, equals 18. So keep in mind, you can check those answers, plug them back into the original equation. Get the part that's being squared by itself. Get that expression all alone. So here, right, now we have just an x squared that we're trying to get by itself. So what can I do? Well, I can divide by negative 2. Right? So when I divide by negative 2 on both sides, I get x squared equals 45. Right? It was equals negative 90. Don't be thinking, oh, it equals a negative. I can't square root that. Well, when I divide by negative 2 on both sides, I don't have a negative anymore. I have a positive 45. And then I would have to square root that. So when I square root that, I'm going to get x equals, and you need a calculator for this one, right? Plus or minus, don't forget that, 6.71. Plus or minus 6.71. All right, number 9. Another example, like 7 here, where we have to get the part of the expression, part of the equation, that expression is being squared all by itself. So we're going to get that whole x plus 3 by itself by first dividing by 4 on both sides. So I can divide by 4 on both sides. 4 there. That would cancel out. I'm going to get 7 equals x plus 3 in parentheses squared. Now I need to square root both sides. Okay? So I'm going to get x plus 3 equals, in this case when I square root the 7, I'm going to get a plus or minus. I'm going to have a decimal, 2.65, 2.65. And I have to solve for both my equations. I'm going to get 2.65 equals x plus 3 and negative 2.65 equals x plus 3. So I'm going to subtract 3 on both sides of both of these equations. Subtract 3 and subtract 3. Okay, so over on the one on the right, I'm going to have x equals negative 2.65 minus 3 is negative 5.65. And then I'm going to have on the left one, I'm going to do 2.65 minus 3. That's going to be negative 0.35 equals x. So there's my two solutions. Okay. Two solutions, in case both of them are negative, that can happen. They can both be negative, both be positive, one of each. We have two different solutions there. All right, in number 10, we're going to start by subtracting the 55 on both sides. All right, so we're going to subtract 55 because we're trying to get that x squared by itself so we can square root it. 4x squared equals negative 40. And now when I divide by 4 on both sides, I'm going to have x squared equals negative 10. When you try to square root that, you're not going to be able to because you're square rooting a negative. Can't square root a negative, there's no solution. No solution. Right? Okay. Keep in mind, when you're using square roots on both sides, you want to get the part of the equation that's being squared all by itself. So here, the x squared by itself. Here, the x plus 3, which is being squared all by itself. Then we square root both sides, and don't forget the plus or minus on both sides when you square root. Right? And if you try to square root a negative, there's no solution. If it was square root of 0, there'd just be the one solution, which would just be 0. The square root of 0 is 0. And also, remember all the things we've seen in here, all the equations we've seen, none of them had a bx term. Right? Here, x squared, there's no term with just an x in it. Here we see just an x, but it's being squared. Right? This whole part of the expression is being squared. So we had no equations where it was an x squared, ax squared, and a bx, and a c, and some other number. Right? So we can't square root unless we can get the square root x squared by itself. Okay, isolate it by itself without an x anywhere else, and then square root both sides.